In order to explain forward reaction and reverse reaction, we again explain graphical representation of dynamic equilibrium in which A react with B and form product C and D. Here, initial concentration of A and B are taken as same and maximum, so that's why initially when A react with B it form product C and D. So as A react with B, for rate of forward reaction increases. So here rate of forward reaction increases. And as products C and D are formed, then they again react with each other and form reactant A and B. So here reverse reaction will proceed. And as time passes, rate of forward reaction decreases and rate of reverse reaction increases. Here rate of reverse reaction increases. Here rate of reverse reaction increases. So as A react with B, it form product C and D. Rate of forward reaction decreases with the passage of time. And as C react with D and form A and B again, so rate of reverse reaction increases with the passage of time. And a time reaches when rate of forward reaction becomes equal to rate of reverse reaction. Forward reaction is equal to rate of reverse reaction. And at this time, concentration of A and B will becomes equal to the concentration of C and D. It means that as rate of forward reaction becomes equal to rate of reverse reaction, then the concentration of reactants must be equal to concentration of products, and concentration of reactant and product must remain constant here. At this stage, equilibrium will be achieved. So this type of equilibrium is known as dynamic equilibrium. Here, what is forward reaction and what is reverse reaction? Forward reaction is the type of reaction in which reactants react together and form products. So that's why rate of conversion of reactants into products is known as the forward reaction. And what is reverse reaction? Rate of conversion of products into reactants is known as the reverse reaction. So what is reverse reaction? Rate of conversion of products into reactants per unit time is known as reverse reaction. A reverse reaction is also described as that when the reaction proceed in reverse direction. Here when the reaction proceed in reverse direction, it is known as reverse reaction, and when reaction proceed in forward direction, it is known as forward reaction. For example, this reaction can be explained as forward reaction when A react with B, it form product C and D. Here rate of conversion of reactant into product per unit time is known as forward reaction. And when C and D, which are products here, they are converted into reactant again A and B. So here C react with D again to form reactant A and B. Here rate of conversion of product into reactant per unit time is known as the reverse reaction. So forward reaction proceeds always in forward direction and reverse reaction proceeds in the reverse direction in our reversible reaction. What is difference between forward reaction and reverse reaction? Forward reaction is that type of reaction in which reactants are converted into products, and reverse reaction is that type of reaction in which products are converted into reactants. Here in forward reaction, it proceeds from left to right, and here in reverse reaction it takes place from right to left. As in such case, here it proceeds, forward reaction proceeds from left to right, and reverse reaction takes place from right to left. Right to left. At initial stage, rate of forward reaction is very fast, but as reactants combine together to form products, then rate of forward reaction decreases and rate of reverse reaction increases. So with the passage of time, rate of forward reaction slows down and rate of reverse reaction speeds up. And at initial stage, rate of forward reaction is very high, as well as rather than rate of reverse reaction, which is negligible. The rate of reverse reaction at start, at initial stage, it is negligible, but with the passage of time, rate of forward reaction decreases and rate of reverse reaction increases. So it slows down gradually and rate of reverse reactions speeds up gradually. Examples of forward reaction and reverse reactions are that NO react with O2, it forms 2NO2. Here NO react with oxygen and form nitrogen dioxide. The forward reaction of this reversible reaction can be written as 2NO plus O2 gives us 2NO2, whereas reverse reaction can be written as NO2 gives us 2NO plus O2, because NO2 decomposes into NO and oxygen. Nitrogen dioxide decomposes into nitric oxide and oxygen, yes, in reverse reaction. Now practice problems are here. When carbon react with water, it forms carbon monoxide and hydrogen gas. Forward reaction of this chemical reversible chemical reaction is that C plus H2O, carbon react with water and forms CO plus H2, whereas its reverse reaction can be written as CO plus H2. They react with each other and form C plus H2O. C plus H2O in reverse direction, so its reverse reaction can be written as. Here another problem, which is that here HCl, 4HCl react with oxygen and it form 2 water molecule and 2 chlorine molecule in forward direction, so its forward reaction can be written as, but its reverse reaction can be written as when 2 water molecule react with 2 chlorine molecule, it form 4HCl plus O2. So here water and chlorine react with each other and form HCl and O2 in reverse direction, so its reverse reaction can be written as.